Okay, lesson 112 is about the binomial theorem, which we've actually already have been using and have already talked about. We just didn't specifically name it the binomial theorem, but this is the binomial theorem written out. So the binomial theorem says that if n is a positive integer and k is a positive integer less than or equal to n plus 1, the kth term of f plus s to the nth power is this expression. Okay, and now if you think about what this is, if you look at this, these two things on the bottom, if you do n minus k plus 1 and you were to add to that k minus 1, these things would add up to k. Okay, so that, remember, like if you see like n factorial over n minus k factorial times k factorial, that's just, n choose k. Well, we have something very similar to that, except we have plus 1 and minus 1 in here. So this is actually n choose k minus 1. Oh, why did I don't? So n, I was wanting to write it that way. N choose k minus 1. Okay. Growing up, I always wrote it this way, within little parentheses, n choose k minus 1. Okay, so it's sort of hard for me to get out of the habit of that. Okay, but anyways, that right there is n choose k minus 1, and then over here, the k minus 1 is the exponent on the second variable or expression or whatever in your sum. And then, of course, this is the exponent on your first variable or expression or whatever. Okay, and of course these two have to add up to n because we're raising it to the nth power. So we've already used this. We just didn't write it out with n's and k's, but this is what we've been doing, probably the way that you've been doing it to find the kth term of, because it's just easier than using Pascal's triangle and writing out row after row after row. Okay. So let's just go ahead and we'll work some examples, and they should be straightforward because you've been doing these. Okay, so we want the 8th term of f plus s to the 12th power. Okay, so to get the 8th term, let's figure out, I think it's easier actually to figure out what the exponent on the s would be, because then once we figure that out, then we just figure out what do we need to add to that exponent to get to 12, and that's what we put on f. Okay, so imagine the first term would have a s to the 0th power. The second term would have an s to the first power. The third term would have an s squared, and so on and so forth. So if we get to the 8th term, we're only going to have an exponent of 7 on the s. So we're going to have an s to the 7th, and so of course we're going to have an f to the 5th, because 7 plus 5 equals 12. Just make sure they add up to 12. Okay, and the reason it's maybe a little bit easier to do that is because it's very tempting to say, oh, the 8th term, 12 minus 8 is 4, and stick a 4 on f. But that's not, it's not 4. It's going to be 5, and it can be confusing, but if you think about the fact that the s had to start at 0, and then it went to 1 and 2, you're only going to be able to list 7 of those because you have to count the 0 as well. So maybe that will help it be a little bit more intuitive. Or you just can remember, if you subtract these, don't forget to add 1 on the f. However it makes sense to you, as long as you do it right. Okay, and then, of course, the coefficient in front of that is 12, choose, and then you can put 5 in there. Or you can put 7, it doesn't matter which one. They are the same thing. Okay, I just usually like to put the first one. Okay, so we're going to put 12, choose 5 in there, and we get 792. F to the 5th, S to the 7th will be our 8th term. Okay, now we want the 10th term of f plus s to the 14th. The 10th term, so that means we're only going to have a 9 on the as the exponent on the s. 9 plus 5 is 14, so we're going to have an exponent of 5 on the f. And then we will have a 14, choose 5. I'm just giving you other notations to look at. Okay. All right, so our 14, choose 5 is going to be 2002, f to the 5th, s to the 9th. Okay, and one last problem. This time, instead of just a simple f and s, we're going to have something a little bit more complicated. All right, so we want the 10th term of 2x cubed minus y to the 15th power. Okay, so one tricky thing is make sure you include the sign with that second term. So we're going to have a minus y, okay, and that will be raised to the 9th power because it'll be 1 less than that. And then 9 plus 6 is 15, so the 2x cubed, that first term, is going to be raised to the 6th power. Just make sure those add up to 15. And the coefficient in front of all of that is just 15, choose 6. Okay, so we've got 15, choose 6 is 5,005. And now we've got 2 to the 6th, which is 64. And then x cubed to the 6th is x to the 18th. Now we've got minus 1 to the 9th. Since that's an odd power, we'll get a negative value. And y to the 9th. Okay, so we need 64 times 5,005, which is 320,320. We get the negative from here. We'll have an x to the 18th, y to the 9th. Okay, so this is what you've been doing all along, so hopefully this is straightforward for you. Just a reminder about how to find the exponents, and once you find those exponents, I'm sure you'll be golden.